How do you debug the memory heap in Node.js? Imagine your application is a busy city, and the memory heap is the city's storage warehouse. Sometimes, this warehouse gets cluttered with unused or misplaced items, slowing everything down. Today, we're going to look at how to clean and analyze this heap to keep your Node.js application running smoothly. First, you need to capture heap snapshots. These snapshots are like taking a photo of your warehouse at a specific moment. You can do this by starting Node.js with the flag and connecting to Chrome Developer Tools. Once connected, go to the Memory tab and click to take a snapshot. Alternatively, you can use the write_heap_snapshot method from the V8 module in Node.js. You can trigger this with signals like sigusr2 if you're using an older version of Node.js. The heap dump package can help generate heap dumps easily. Once you have your snapshots, load them into Chrome Developer Tools or similar tools to analyze. Look for objects with large retained sizes, which show how much memory would be freed if those objects were garbage collected. Keep an eye on objects whose count or size keeps increasing over multiple snapshots. That's a sign they might be leaking or not being released properly. Also, pay attention to familiar object types or your own classes that seem to stick around longer than they should. To reproduce memory leaks reliably, try to perform the same actions or load patterns that cause the issue. Taking snapshots before and after these actions helps you compare and spot what's growing unexpectedly. Running Node.js with the expose_gc and trace_gc flags can give you more insight into garbage collection activity. These flags let you see when garbage collection occurs and how much memory it frees, helping you understand if objects are being cleaned up correctly. A good workflow involves taking a baseline snapshot before a suspected leak, then performing the operation or load, and finally taking additional snapshots afterward. Comparing these snapshots reveals which objects persist or grow in size. Be cautious when doing this in production, because generating heap snapshots can pause your application and use extra memory. It's best to do this in staging environments or on processes that can be restarted safely. You can also use monitoring tools to track memory trends over time, or set up HTTP endpoints or scripts to trigger heap snapshots on demand. Just make sure these controls are secure and not accessible publicly. Regularly updating Node.js helps because newer versions include better diagnostic tools and features for debugging memory issues. By following these steps, you can systematically identify memory leaks and fix them. This process helps keep your Node.js applications stable and performing well. Combining Node.js-specific tools with general debugging practices makes it easier to solve heap-related problems effectively.